All right, good morning, everyone. I hope everyone's having a great day today. Braved the weather and came into class. That's always good to see. So we're going to be inside the Excel file today for Analytics Supplement. Should be found in Canvas. So I'll give you all a minute to pull that up. While you are, I just want to remind you of a couple things. Last class I mentioned that we won't meet in person for the 18th, which is Thursday. Probably won't meet in person for the 23rd either. What I'll do is, since we have 3 days to present Chapter 11, I'll just do one of those two, probably that 23rd. I'll just put something on my YouTube channel if we don't end up meeting in person. But I'll certainly send out email updates about that. I did go ahead and push back the Connect Master assignments that were going to be due on the 18th. I pushed those back to the 25th at 11:59 p.m. It's one of those things I'd encourage you to go ahead and do them, but since we aren't meeting, I figured I'd just push them back, just to be fair to everyone. So any questions before we begin? All right, so like I said, today we're going to be in Excel doing some basic analytic exercises. Think back to the last class. We talked about a lot of the theoretical components of analytics and how they kind of are used by firms. Today's all about just doing this stuff. So some of the stuff we'll cover today may be a review for some of you. Some of it may be new. We'll just kind of start from the basics. So I've got a column here of functions and operators. These are things that you're bound to see on the exam. I'd be willing to place a lot of money on it. You should never take me up on a bet when it comes to exams because, well, I make the exams, so that'd be a losing bet for you. But a winning bet for me. So if you want to lose some money, let me know. But apart from that, I'm going to assume that you don't. So the basics of this is I'm just going to go through these, talk about what they are, talk about how they're used. So the first function we have, or the first operator rather, is a subtraction sign. As you may guess, it's used to subtract two things. So there's a couple different ways you can start off an Excel formula. You can either use equals or at. I'm just going to use equals. So we can type in two values. I can do 2 minus 1. Of course, that's going to get us 1. I could also come over here if I wanted to use a relative reference. Just click on one of these cells and subtract off another cell. Perfectly fine to do. Like I say, some of this will probably be a review. Next, we have the parentheses. It's going to be used to change the order of operations in Excel. So you'll think back to your math classes. You had please excuse my dear Aunt Sally. Parentheses and exponents come first. Multiplication, division comes second. Addition, subtraction comes third. So we can change the order of that. That's the default order in Excel as well. So if we want to do, say, 3 minus 2, and then we want to do times 2. So what this is going to do is this is going to do 3 minus 4. Should give us negative 1. But all we have to do to change that, just put in our parentheses here. And of course now it's going to give us 2 because we're taking this subtraction first, then multiplying it by 2. So we're taking 1, of course 3 minus 2 gives us 1, multiply that by 2, gives you 2. Pretty basic so far. Of course I just kind of used the multiplication in that, so all you got to do is just use the asterisk symbol to multiply things. You can do 5 times 2, whatever you want to do there is fine. Same with division. You can take a number, divided by another number. Perfectly fine to do. Addition, you can do the same thing just like with subtraction. Pretty straightforward so far. Then of course we can use average. So now we're going to get into the functions. So all those that we had before, they're just operators. But the functions are going to allow us to do some more advanced things. So of course to start off a function, same way you start off any equation, put the equal sign, type the function name, open up parentheses. Now here's where you can kind of tell it what data you want to average. So I could put in 1, 2, 3. Of course the average of that's going to be 2. I don't have to do it that way. I could also give it a range to average. So I'm just going to select this range right here, and it gives me an average of it. So pretty straightforward there. It does get a little bit more exciting here. So what we're going to do now is we're going to use the average if. And the average if is going to allow us to average something if it's within inside of the relative condition that we have. So what we do is we start off by just typing in average if. We tell it what range we're looking for the condition. We tell it what the condition is. And then we tell it where we actually want to average. So that last part is going to be optional. So we just type in average if, open a parentheses. Again, we're going to first get the range. So we're, in this case, going to look for something that is going to be the value 2. And we're going to do that inside the G. column. So we just collect the G column here, use our comma, say whatever the criteria is. In this case, we're going to use 2 because we're going to want to average anything that has a 2, and specifically, we're going to want to actually use the average range of F. And the reason we're using the F column for average range is because if we average 2, it's going to be 2. That's pretty obvious. So we're going to use the F column to actually give the average of that. And it gives us 5.5. So again, that last part is optional, but without it, it's not really that useful of a thing. So certainly we want to keep that in mind. Okay, and we can also use count. So as the name would imply with count, it gives you the amount of observations inside of the range that you specify. So for example, we could do something like count and just select a column. Whoops, had the parentheses the wrong way. Gives us 11. Means there are 11 observations inside of the G column. So that certainly makes sense. If we were to count these, we could just see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Pretty straightforward there. What's a little bit more cool is we could do something like a count if. So all we have to do is just start it off, say count if, and we're going to tell it where to count. And now we can do a range. So in this case, I'm going to make sure it's going to be greater than 2. And when we do that, we see there are 3 numbers here that are greater than 2. And that's absolutely correct. One thing to note here is that you actually put the condition inside of quotation marks. So that's a thing that's a little bit different. If we didn't do that, it may cause us some issues, so just make sure you have it in quotation marks. Next, we could do an if. So we could do something like if, let's just say 2 is greater than 4. So we know that 2 is not, so we're going to say false. True. Whatever you want to put here. So in this case, it's going to run that condition. If it's false, it's going to do, it's going to give us true. You get the idea there. Of course, we could then sum. So as you'd imagine, sum is going to add values for us. So we have a couple different options here. We can literally type in numbers. We could do 1, 6, 0, 4. That's certainly one way we could sum values. Of course, we could also use a range. And we could use multiple ranges. So we could go ahead and do this first sum right here, put a good friend of comma in there, go ahead and add in the second range as well. And that gives us a total of 76. We could also use sum if. So like with the average if, it's going to allow us to do a sum if we meet some specified condition. So what I'm going to do here is I'm just going to go ahead and type in sum if, use the G column. We want it to be greater than 1. And we actually want to add the F column. So we don't just want to add a bunch of values that are greater than 1. We want to specifically add the values in the F column that are associated with them. And that gives us 44. We could also do sum product. So sum product is going to be used to multiply 2 arrays together. So an array is just going to be a column of values, basically. So all we have to do is set that up. Is just tell it which arrays we want to multiply. So we take sum product. We can multiply the F column and the G column. And what this is going to do is this takes 1 times 1 plus 2 times 1 plus 3 times 1 plus 4 times 1, 4 times. You get the idea. So that's what it's doing inside of the sum product. We could also use VLOOKUP if we wanted to look up a value associated with something. So let's just say we want to do this. First thing we're going to say is what value are we looking up? So we could just use 5. And where are we going to find it? We're going to specify these 2 columns right here. It's always going to look inside the first column that you specified, but the reason I went ahead and specified 2 columns is so that way I'm able to reference another column. If I only specified the 1 column, I wouldn't be able to reference any other values. So I don't actually want the 5. I know 5 exists. I want the value associated with it, which is in the next column. So now we say what the column index number, which in this case is 2, because the first column is the F column. Second column is the G column. We're interested inside the value that is inside the second column. So in this case, we're going to say 2, and we're going to say false to make sure it's an exact match. And as you can see, what it does is it goes to the 5 that you specified. There's only one 5 inside of this column, and it goes to 2 value. So that's what it does there. Certainly a very powerful thing, so certainly make sure that you know that. Then we have absolute versus relative references. So an absolute reference is going to stay the same no matter how many ways it's copied, whereas a relative reference is going to change whenever you copy it. So what this looks like is you would type in a $sign before whatever you wanted to have. So if you had $B, $4, that means that both the row and the column are going to be static. They're not going to change whenever you copy a formula around. And we'll see some examples of this in a little bit, so don't get too caught up on it. But if you wanted to have a relative reference, it would just look like B4, or whatever the sort of column and row were. Now, of course, you could do just a single one of these. So in this case, I'm only going to hold the column constant, whereas the row is going to change. And you could use that for some things. You could also do the reverse of that. You could hold the row, let that kind of change, but then have the row stay the same. So you would have the column change, rather, but the row would stay constant. So lots of different options for how you could go about that. Any questions about any of those? All right, if I'm going too fast, let me know. I'm certainly willing to explain things again if I need to. Of course, you could also watch the YouTube video if you need to do that as well. Certainly okay. So now we're going to talk about forecasting a little bit. So basically, the whole idea is we want to predict future values, and we want to do that using past values. So we're going to talk about some different types of forecasting. You may want to write these down. I don't believe they're found anywhere else. I don't think they're in the book or anything. So I'll go slowly if you want to write these down. Of course, you don't have to write anything down. It's completely optional, but it'll be on the test, so you probably need to know it. So the first one is naive forecast. And what we're doing when we take a naive forecast, we're taking the previous observation, and we're assuming that's going to be the next observation. So, you know, you can think about that if you want to memorize it. Think about, is that a smart thing to do? Probably not. Why would we assume that the previous value is going to equal the next value? That seems like there are better ways we could forecast. So you could say it's kind of naive. So if we had this data right here, let's just assume that this is the data we're wanting to predict from. And if we were taking a naive forecast, we wanted to predict the 12, so let's just say these are months. Don't have to be months, but we're just going to assume they are. So we're wanting to predict the 12th value. So all we'd have to do is just take the previous value that we have, which is 11. Or which is the 11th month, rather. It's going to be equal to 8, of course. So if we want to take a simple moving average, what we're doing is we're taking an average of a set amount of periods. Typically, we think of the amount of periods as being 3, but we could do any amount of them for the moving average. So what we're going to do is we're just going to take an average of the 3 most recent values. So we're just going to type in average, and then we know that the 3 most recent values are 7, 7, and 8. So we're just going to select this range right here. And that's going to tell us that our simple moving average for this, if we're using a 3-period moving average, it's going to be equal to 7.3 repeating. Then if we want to do a weighting moving average, I think we talked about this last class, how I said you'll be given the weights. So the weights must add to 1, because if they don't add to 1, it means you're taking the values and you're changing the relative weight of them. You can't do that. Well, I mean, you can, but you shouldn't. So what I'm going to do is I'm just going to use the weights of 0.7 for the most recent value, 0.2 for the second most recent, and 0.1 for the third most recent. Those are completely arbitrary. Like I say, on an exam, you'd certainly be given whatever the weights are going to be. So all we have to do is take the first weight, 0.7, multiply it by 8, and then you're going to add in 0.2 multiplied by 7, and then lastly add in 0.1 multiplied by 7. And we don't have to worry about parentheses here because we know from the order of operations, we're first going to multiply, and then we're going to add. So when we do that, we get 7.7. Now, let's say I don't want to use 0.7, 0.2, and 0.1 as my weights. Do I have to use them? No. Let's do 0.5 for the first weight, 0.3 for the second weight, and 0.2 for the third weight. That gives us 7.5. So we can use whatever weights we wanted. If we got a little bit crazy, we could even use 1 for the first weight and 0 for the other 2 weights. What's that going to give us? That's going to give us the same thing as naive average. or the naive forecast rather. So it's not really going to give us an average so much as it's just going to give us the most recent value. Simple exponential smoothing sounds a lot more complicated than it really is. Basically, the whole idea is you have a smoothing constant, which is going to be defined as alpha. So you have alpha, just a smoothing constant. And what you're trying to do is that number has to be between, or it can include rather, 0 to 1. It can be 0, it can be 1, it can be anything in between that. Can't be larger, can't be smaller. So what we have here is we have 0 greater than equal to alpha greater than equal to 1. Not the best drawing there, but I think it gets the point across. So specifically what we're doing with this is we're taking that alpha and we're multiplying it by the most recent occurring value. Then we're taking 1 minus that alpha and we're multiplying it by the most recent forecast value. So I'll write that out just so it's more clear. So what we have is we have the smoothing at time t. It's going to be equal to previous value, t minus 1, times alpha, plus the 1 minus alpha, and that is going to be the most recent forecast value as t minus 1. So that's all we're doing there. We're just kind of taking those two values. It's really simple to actually calculate. Looks a lot more scary than it is. Does that make sense to everyone? Did I lose anyone on this? All right, let me know if there's any questions. I'm happy to address them. Whoops, I just minimized my sheet here. So what we do, we could pick any number, 0, we could pick that, we could pick 1, we could pick anything in between. I'm going to pick 0.5, because if we take 0.5, it's going to give us a nice clean value here. So what we're going to do is we're just going to take 0.5 multiplied by the most recent occurring value, which is going to be 8. We're going to add in 1 minus 0.5, which of course is just 0.5. Multiply that by the most recent forecast value, which in this case is 7.5. And what that does is that applies a weight to both the most recent occurring value and the most recent forecast value. So that's all that's really happening there. So we could go back here, we could certainly change this. Let's say that I give you an alpha of 7, or 0.7 rather. So then we have 0.7 times most recent occurring value, 1 minus 0.7, which of course is going to be 0.3, and we just multiply those together. It's going to place more emphasis on the most recent value. If we change this to 0.3 for alpha, it's going to place less emphasis on the most recent occurring value. So mathematically, that's all that's really happening there. Does that make sense? Okay, so an easier one to do would be seasonal naive. We're not going to be able to show an example of this because we only have 11 months worth of data. If we had 13 months of data, I could show you an example. But basically what you're doing with seasonal naive is you're not just taking the most recent occurring value and calling it your forecast. You're taking the most recent occurring value of the same period for the most recent year that you have. So for example, let's say we had quarterly data. And we had quarterly data all the way up until Q1 of 2021. And we want to predict Q2 of 2021. We would take the value from Q2 of 2020 and use that as our most naive forecast for seasonal naive. Does that make sense? Okay. And then we have that whole concept of seasonality. Basically, that's saying what effect does the time period have on the data? And we're going to see some examples of how to calculate the seasonal constant. But the whole principle is that you have some total sort of annual estimated sales. And you also have your monthly sales. So you could take the average of your monthly sales divided by the average of your total annual sales. That's going to give you a seasonal constant. You can take that seasonal constant and then you can multiply it by any sort of future trend prediction that you have to easily get wherever you're trying to predict for a given period. So we can use any period we want. We could use quarterly. We could use monthly, weekly. If we had daily, we could do daily. There's no real limitation as to how we could actually do that, as long as we have the data to support it. So that's kind of what we're talking about there. When we talk about trend, we're talking about changes over time. It's going to be greater than 1 year, but it's going to be typically less than about 10 years. I would say you'll generally target about 3 years for trend. It can be a little bit more, a little bit less, but it can't be any less than 1 year, because if you're just looking at 1 year changes, you're basically looking at seasonality. So of course, to forecast, all you'd have to do is just take the trend, multiply it by what you're expecting to see. Then of course, lastly, we have cycles and cyclicity. So cycles are going to be changes over the course of a business cycle. So recession to recession, peak to peak, however you want to think about it. If you're looking at changes across an entire business cycle, this is going to be more relevant for looking at industry analysis. We're considering which industry is going to be resistant to things like recession, which industry is going to be heavily motivated by things like recessions. Certainly, different industries are going to have differences there. Construction industry, pretty famous example of an industry that is heavily not resistant to recessions. If there's a recession, people likely aren't building a whole lot. And if that's the case, it means that the construction industry is not likely to be doing well during periods of recession. Contrast that with something with far less elastic demand, like let's say pharmaceuticals, or we could also use an example of like a food store, particularly a discount food store. It's going to be a lot more resistant because there's going to be demand that is not going to be able to be changed as rapidly as, say, the demand for construction. So certainly that's what we're talking about there. Any questions so far? All right. So now I just want to kind of go through an example of how to calculate grades. So we're just going to kind of go through these and kind of show how you could actually calculate these. A lot of different ways to do it. This is just the first example that I have for today. So, of course, in this class we have several different types of assignments. We have quizzes, we have exams, and we also have Connect Master. So I'm just going to go ahead and add in a column for Connect Master. And someone throw me some numbers. Let's start with 100. Who else has a number? 78. Any other numbers? Keep throwing them. Couple more. Whoops, I typed in 8. All right, so we've got some grades there. Hopefully they're not your grades, because some of those are not as high as they maybe could be. But what we're going to do, we're just going to go ahead and average these. So we're just going to take an average of these grades right here, and gives you a 62.9. Now, luckily, I do add in 10 points to that. So take the average plus 10. And of course, that's just to address any problems with Connect Master. If there's a question that's graded wrong, something's not clear. I think 10 points is pretty fair. I haven't had any complaints, so I'm assuming most people agree. So yeah, that's basically all you're doing there. Then, of course, you have the quizzes. So for the quizzes, you could just take a straight average, and that'd certainly be okay to do. But what do I say about quizzes? Do I average all the quizzes, or do I average the 12 best quizzes? So I drop the lowest quiz grade, don't I? Now, do you think that I manually drop the lowest quiz grade for 200 people? I don't think so either. That'd be way too much work. So what I do instead is I just take the sum of the 12 highest, subtract off the lowest, and then just divide by the count minus 1. So let me just show you that. So we're just going to take the sum of the quiz grades here, and we're going to take off the min. So that's going to be the minimum value. In this case, it should be 0. And just kind of check our work as we go. I'm just going to hit enter, and you can see 1200. And that seems correct so far, because we know there's 13 quizzes. There's 1 0 up here, so it seems like to me it subtracted off 0. So now we just divide this by 12, or you could do this divided by count minus 1. So it's going to give us the same thing if we divide by 12 or count minus 1. And it gives us an average of 100. So we're good so far. Now I just want to average the exams. So in this case, I'm just going to take the average. Gives you an 85. But as you know, of course, I take 3 different averages, really. I take the first average of being like what I just did. Take the second average, where it's going to be only counting the second exam for 20%, counting the third for 40%. And then the third average I take is counting the third exam for 40%, the first exam for 20%. We're not going to worry about that for this, but that's how you would do it. And then lastly, it doesn't look like this person got any bonus points. Bonus points given on final grades, something I do from time to time. They just be factored in as a weight of 1. So certainly keep that in mind. That's not to be confused with the bonus points that I apply to exams. The bonus points that I apply to exams just go straight in the exam grade. So we're just going to put a 0 here. And now we've got a couple different options for how we want to weight this. Of course, we could take the weight, multiply it by the score. That's certainly one way. And we add these together, that's going to give us a course grade. So 85. We could also do this another way. We could, of course, take the sum product here, and this would allow us to kind of go through and just kind of take the different arrays and multiply them together. So let's see what that looks like and see if that gives us the same thing. So we're going to take the weights, put a comma, select scores, close it out. Of course, it gives us the same thing because all it's doing is just taking the two columns, multiplying them together, and then adding the residuals there. So, any questions so far? All right. So now, let's take a quick look at this monthly data. So, what we're going to do is we're just going to kind of talk about what this is. So, this is actual data from a place that I gathered it. Let's just leave it at that. It is some sort of sales data. I'm not going to go into details, but this is units. So basically what this is a service industry in which each of these represent some unit regarding the sales. So, think of this as not necessarily selling a product, but selling a service. So imagine if you had 1,200 count, that refers to 1,200 service calls. So kind of keep that in mind. So if we look down here, we actually see that each month has a cost of 1,200. So regardless of how we do this, we know we have fixed costs of $1,200, and we can have sort of variable costs associated with it. We're only going to look at the fixed costs and see what is the average cost for each month. So all we have to do for this is we just take that 1,200 and we just divide it by whatever the value is. Because the 1,200 is a constant cost. It's fixed. So we're going to take that, and notice we're going to leave this as a relative reference because we want to copy it down. We want to make sure that we're changing the count. So to copy things down, click inside the cell. At the bottom left, or the bottom right corner, there's going to be like a little box here. You just want to mouse over that until you see this black plus icon. Grab it, and you just copy it all the way down like that. And as you can see, it's going to update for each of these. So we have C2, C3, C4, and so on. So that's going to allow us to easily copy this down and kind of see what is the product cost for a given month. So we could get a lot of good information from this. We could do like the max product cost to see which month costs the most. We could certainly do average product cost, see what the average product cost is. We could really do a multitude of different things with this. But the whole idea is this is looking at the fixed cost and seeing if we take that fixed cost and we divide it by the amount of calls that we have, what is that going to equate to? So, does that make sense? All right. So now what we can do is we can do the sum by year. And there's really a lot of different ways we could do this. So what we're trying to do is we have 3 years of data. We have year 1, year 2, and year 3. So we could do this a very simple way. We're going to add all these together, and that should give us the year 1 totals. Now, is that the best way to do a sum? It's going to take way too long. So instead, what we could do is we could use sum. And all we have to do is just grab these values right here, and that's a much quicker way. But can we do it even quicker than that? I think we probably can. So we're going to use SUMIF, and we're going to grab the year, because that's what we're actually looking at. And because this is year 2, we're going to select the condition to be 2, and we're actually going to add in the C column. So, first you get the range of what you're actually wanting to look at, then you get what the condition is, and then you get what you're actually wanting to add. So we just close this off, and that gives us the year 2 total. So I'm just going to copy this down, and we're going to change this to be 3 for this third year here, and that gives us 31,000. Okay, so now we have what happened in year 1, we have what happened in year 2, we have what happened in year 3. So all we did is we just took the sums of those. Next, what we want to do is we want to look at the average annual trend. So for this, what we want to do is we want to take this year 3, we want to divide it by this year 1 value. We're going to subtract off 1 because if we don't do that, it's going to give us a value that's going to be in the hundreds %. We don't want that. And then we're just going to divide that whole thing by 2 because we're looking across not just 1 year, but we're looking at the difference between 2 years. So we're going to divide that by 2. If we weren't doing it that way, we wouldn't have to worry about the division. So we're just going to take this F4 divided by F, whoops, I'm not in the right thing there. Forgot to start it off with an equals, that's my bad. F4 divided by F2 minus 1, and then divided by 2. And that gives us 28%. So when we do that, we know that we have an average annual growth of 28%. So if we wanted to multiply that out and see what year 4 is likely to be, all we have to do is take the previous value, multiply it by the average annual trend, which is 28%. Now, if we do this right now, what's the problem with this? So the problem is that we're multiplying it by 28%. We want to multiply it by 1 plus this. So we're going to do 1 plus 28%. And that gives us a much more reasonable figure. So all we have to do then is then multiply it out by the seasonal constant, which we're going to calculate in a little bit here. And then we can see what we predict for the next years for each of the months. So before we get too ahead of ourselves, though, let's go ahead and do the average by month. So again, there's a couple different ways we could do this. We can manually take the average of each of these. So we could just get average 1, go to the next occurrence of January, and then go to the third down here. And this would be a reasonable way to do this. We can copy this down, and that's going to go ahead and change all of the relative references. This will work. But this is not the easiest way to do it. So we want to do it even easier than this. We're going to do average if, and we're going to get the column for the range. Now in this case, we're going to use a relative reference to tell what we're wanting to average. So we're going to get this criteria. We're just going to select it as a relative reference for the specific month. And then lastly, we actually want to average the C column. So we're just going to do that, and that should give us the exact same values here. And it does, which is very good. So that's what we're doing there. We're just taking those averages there. So now what we can do is we can just go ahead and get the grand total. So the grand total is simply going to be the sum of all of the observations. So we're just going to take the sum of the counts. Okay, and that gives us 80,848. So now what we can do is we can go ahead and add these up. And this is going to be an average, so we know that this should be 1/3 of the grand total. And if we take this number right here and we multiply it by 3, it gives us the same value. Because all we did is we took the average. We know there's 3 periods, so to get out of the average, just multiply by 3. Should work perfectly fine. So now what we can do is we can actually kind of calculate the seasonal constant. So to do this, we simply take the month, the average by the month, divided by, in this case, I'm just going to keep it simple. I'm just going to use this average overall. It's going to be for the overall amount that we get on average. And I'm going to make this an absolute reference, so when we copy it down, it doesn't change the reference of the cell. And that gives us 0.1. These seasonal constants, if we did this correctly, they should add to 1. Because what we're doing is we're saying what proportion is explained by a given period. So if the period is expressed as being 1, that means that 100% of the sales occur in that period. And if we have other periods, it means that nothing else occurs inside of them. That's unlikely to happen. If it does happen, it means that your business probably is only open for 1 period. Maybe it's a seasonal business. That certainly could be the case there. We're just going to go ahead and remove these two. But as we can see, when we add those, it's going to give us the 1. So that's certainly what we'd want to see there. So we have the seasonal constants. Now what we can do is to get the year trend forecast, we can take this value right here, which is going to be the expected amount of total sales, and we just multiply it by the seasonal constants to give us what we anticipate seeing for one given month. So we're just going to do that. And that gives us, we expect to see 4,000 calls in January. Now I'm going to show you what happens when we don't use an absolute reference when we should. See how these are all 0? So because I didn't make this an absolute reference before I copied it down, it's going to look further down, and since there's no value there, it's going to multiply by 0. So we're just going to change that by making that an absolute reference. And you can do that a couple different ways. I usually just hit F4 on the keyboard when I have the cell, the cursor on the cell. But you could also type in manually the $signs before each of the row and column. So a couple different ways you can do that. Now when I copy this down, it works just fine. So, all we did is we multiplied these by the seasonal constants. If I add these, what value should I get? Anyone want to take a guess at what value I should get if I add up those sort of monthly trend forecasts? So this value right here, that's exactly correct, because all we did is we multiplied that by 1. So if I add these together, that is exactly what I should see. And you'll see that it's exactly what we see. So that's certainly good. That means that what we did is likely correct. So that gives us up until this point. So let's go ahead and look at the naive forecast for January. So we have 3 years. We're just going to assume that 3 is the most recent year. Maybe it is, maybe it isn't, but it doesn't really matter for this example. If we're to use the naive forecast, what would that value be for January of year 4? The most recent occurring value, which is 1,895. So we can literally just make an absolute or a relative reference here for this value. And that is the naive forecast. That's all we have to do. Then we have the seasonal naive forecast. So we're going to look at the January for year 4. So all we have to do is go back to January year 3, and that is going to be the seasonal naive forecast. So probably going to be closer to what we'll actually see. It'd be pretty unlikely that we see 1,895. Simple moving average. All we have to do is take an average of the 3 most recent occurring values. So we're just going to average these 3. And it gives us the simple moving average. Then we have the weighted moving average. So I'll take weights from the audience. Someone give me 3 weights. They have to add to 1. Okay, we can certainly do that. So we'll use 0.2 for the most recent occurring. Multiply that by the most recent occurring. Now we're going to add in 0.3 was the next weight. So 0.3 times second most recent occurring. And then 0.5 for the third most recent occurring. So those, in fact, add to 1. Therefore, we can use them. And that gives us the weighted moving average. So we can use literally any weights as long as they add to 1. So the simple exponential smoothing, I'm just going to say alpha equals 0.2. So what we do is we take that 0.2, multiply it by the most recent occurring value, which I don't feel like going all the way back over. I'm just going to use the naive forecast. Then we're going to add in 1 minus 0.2, and that's going to be multiplied by the most recent occurring forecast, which we're just going to assume is the weighted moving average. On an exam, you would be given what the most recent occurring most recent occurring forecast value would be to use. So you would be given that. So we do that, we get the simple exponential smoothing. Does that make sense to everyone? Should I go over anything again? Is that clear? Any questions at all? All right, well, we've got a little bit more time, so I'm going to go through the quarterly data. I'm going to go a little bit faster this time, just because it's very similar in how you would handle it. But basically, for quarterly data, it's just going to be, instead of having it in months, we have it in quarters. So we have 4 quarters in a year, as you would anticipate. And really, that's all we have to do. So we're just going to get the sums of each of these. So we can do SUMIF. And we're going to look at the year. We're going to see if the year is equal to this year. And then we're going to actually add the revenues. So we're just going to copy this down. And shouldn't have done that for 2018. So you'll see, previously the data was in ascending order. Now it's in descending order. And what that means is that the most recent occurring value is at the top instead of at the bottom. So we're just going to go ahead and do the average by quarter. So now we can do average if. And we're going to do this range to look at the quarters. We're just going to select this right here as the quarter that we're wanting to average. And then lastly, we're wanting to average the revenues of the quarters. So we're going to copy this down. And that gives us the average by quarter. Now, what we want to do is get the grand total. So let's take the sum of revenues. Make sure there's nothing below it. Yep, it looks fine. 4 years of data. So quite large values. So I'm just going to go ahead and take the sum of all these. And for the seasonal constant, since I just added the averages by quarter, I really have a couple different options. I could either take the grand total and multiply by, or not multiply rather. Well, you could multiply by 0.25, but I was going to say divide by 4. That's one option because there's 4 years. Or what you could do is just take the sum of the averages and just divide by that. So what that looks like is you take this first value divided by this total value for the years, for the averages of the quarters rather. Make that an absolute reference, and that gives you 0.21. And as you see, these add to 1. So basically, all we just did there is we took that, and we can see that, as we would anticipate, because the fourth quarter has the highest average, it has a seasonal constant that's slightly above the average. So if we had data with 0 seasonality, the seasonal constant for each of these quarters, we would anticipate to be very close to 0.25, because that means that there's relatively little effect of the time period on the revenue in this case. But because we don't have that, we anticipate seeing a larger quarter 4. A lot of holiday shopping around quarter 4, you know, Christmas and all that. Probably some other holidays thrown in there as well. That's going to anticipate having a larger sales. So we see that here, which makes sense. So now we can go ahead and kind of see what we anticipate seeing. So let's go ahead and take a look at the Naïve forecast here. So we have the Naïve forecast. What is it going to be for 1 of 2018? So it's going to be this value right here, most recent occurring revenue. If we want to do the seasonal Naïve, we go to the most recent value of quarter 1, which is quarter 1 2017. So we're just going to take this value. That's all we have to do. Simple moving average, take the most recent 3 values. Average those. Weighted moving average. Again, we're just going to use some random weights. Anyone want to throw some weights at me? 0.8, 0.1, 0.1. Okay. So we're going to take that 0.8, multiply it by the first revenue, add in 0.1 times the second most recent revenue, and lastly add in 0.1 times the third most recent occurring revenue. So we do that, gives us the weighted moving average. And then lastly, we have a simple exponential smoothing. Anyone want to give me an alpha? 0.4, okay, we can certainly use that. So we're going to take 0.4, multiply it by the most recent occurring value here. Oops, I don't think I was in a formula. Forgot the equals sign again. So again, we're just going to take that by the most recent occurring value. And then we're going to add in 1 minus 0.4 and multiply that by the most recent occurring forecast, which we're just going to use the weighted moving average here. And that gives us a simple exponential smoothing for this. Okay, so on the exam, which isn't until the 22nd of April through the 28th, you'll have that entire final exam window to take the exam. Of course, once you open it, you only have 3 hours, but that's kind of typical. So basically, on the exam, you'll be doing stuff like this. So if you have any questions, I'll stick around for a couple minutes after class. I'm happy to take a look at anything if something isn't working well. But apart from that, I hope you all have a great day. I will see you all either next Tuesday or next Thursday. So definitely won't be in class on this Thursday. Have a good one, everyone.